Okay, so the last video we talked about the nitrogen cycle. Hopefully for this video, which is going to be the sixth video, part 4 of the notes, sixth video, part 4, okay, of week 4. So the last video we talked about the nitrogen cycle. This video we're going to be talking about the phosphorus cycle. So hopefully we can get through in this whole video all of the nitrogen cycle, or the phosphorus cycle. Okay, so we're going to start with sinks. Okay, again, these aren't kitchen sinks. They are where these phosphorus compounds are going to be located. Okay, so first part is going to be this one here, the organic phosphorus, organic P. Okay, it can be labeled in a couple different things. The microbial content of the soil can be the plant residues within the soil, or they can be the humus. Okay, not the humus, the humus of the soil. Okay, which is like the dead leaves and dead plants and stuff, dead organic matter on the soil or within the soil. Okay, humus is going to be good stuff for your garden if you are interested in that. Okay, so organic P can be the soluble P. So that's going to be H2PO4. So those are going to be hydrogen phosphates. And that's just a different hydrogen phosphate. So two different kinds of hydrogen phosphates. You don't got to memorize those, but in case you wanted to know. Soluble Ps. These are going to be, well, from organic Ps, these are going to be our soluble. They're going to be dissolved within, or a little bit more diluted within the soil. Okay. Secondary compounds, these are going to be here. Okay, those are going to be formations made from the phosphorus. And then the last one's going to be our mineral surfaces. Okay, we're going to talk about what these words mean. They're going to be labeled within different minerals. Okay, different from the nitrogen cycle, I'm going to label sources. Okay, because we can get these from a couple different places. One particular reason why I did this is because of primary minerals. Okay, unlike the nitrogen cycle, we can get phosphorus from rocks. Why I thought this was a source and not a sink is that nothing ever goes back to a primary mineral. It only goes one way, so it doesn't ever go back. So that's why it's more of a source and not just a sink. Okay. We also can get it from animal manure and biosolids, plant residues right here. We can get it from the atmosphere in the form of dust, and then we also can get it from fertilizers. Okay. So movement from these places. First one's going to be our decomposition. Okay. So from our animal manures, biosolids, plant residues, it's going to decompose. Okay. Decomposer's going to latch on to this organic matter, which that's all this is, organic matter. It's going to break those down into organic phosphorus. Okay. It's going to be organic phosphorus at that point. From organic phosphorus, we're going to get mineralization. This is organic phosphorus moving to a soluble phosphorus. Different bacterias, different things are going to, microbes are going to take that phosphorus and we're going to stick on some hydrogens and some oxygens onto it to make it different things. Okay, so that's going to make it soluble. So we're going to have organic P being transformed into soluble P. The opposite of that can be called immobilization, when different compounds are going to break down soluble P into organic phosphorus. Okay, kind of like when we were looking at the nitrogen cycle, how there's nitrification and denitrification. This is kind of like phosphorization and dephosphorylation, but it's mineralization and immobilization for each of those respectively. Okay. Weathering. This is going to be from our primary minerals, so our different rocks, they're going to weather and they're going to give out soluble phosphorus. Okay, so they're going to trade, or they're going to give off soluble phosphorus in the weathering process. Those rocks break down, give off soluble phosphorus. More movement. Okay, adsorption, not absorption. Okay, like a paper towel. Adsorption. Okay, adsorption is different than absorption. Absorption means something takes it up. It's plant uptake is absorbing. Adsorption means it's sticking to. Okay, so soluble P in absorption is going to stick to the surface of these minerals. Okay, clays, Fe, which is iron, and aluminum, Al, oxides, and carbonates. They're going to stick to those different compounds within the soil, and then they're going to be used within that soil. Okay, This is how it's not labeled here, but this is one of the reasons why we get dust. Okay, these compounds are going to break down, these components within the soil are going to break down into smaller and smaller pieces, and they're going to get picked up by the wind. That's how we're really going to get dust. Okay, but this is too small of a diagram, I guess, to show that. But adsorption is when it sticks to the surface of those things. Desorption is the opposite. Okay, they're going to get off of the surfaces, and they're just going to be soluble P within the soil. Okay, not on the surfaces of the soil, but just in the soil column, somewhere in there. Precipitation. We know a definition for precipitation. There's going to be a different definition. Okay, so precipitation is going to, in this case, is going to be when two liquids combine to create a solid and a liquid within a chemical reaction. Okay, so when we put two liquids together, one way that we can have them react is in a precipitation reaction where liquids come together and a solid is produced and a liquid is produced. In this case, the chemical reaction is going to create a solid of these compounds. Okay, so you're going to get soluble P mixing with other things to create these compounds. Now, the opposite can happen too. These compounds can break down and then come out into soluble P. So it can go forwards, it can go backwards. Okay, just like you can see with all these other things. Forwards and backwards. More movement. Okay, leaching. Leaching in the phosphorus cycle, very minute. Okay, not a very big deal, usually minor. Okay, most of the time, because it's going to get picked up by plants, and it's going to get picked up and done into other different places. Okay, so not a whole lot's going to leach out. Okay, but when something leaches, that soluble P is moving. That's it. Okay, it's moving from this location to another. That could be to a body of water. That could be to another part of the soil, deeper in the soil. It's just moving from the soil to either water or further in the soil. Plant uptake is when plants are going to take up through their roots the soluble P. This is going to be the useful stuff. This is going to be like a fertilizer for them. They're going to want this stuff. They're going to want to take that phosphorus. Okay. Runoff can happen a couple ways. Runoff can happen when dust gets onto the soil and then water pushes that dust off into a larger body of water, or mineral fertilizers are going to get put onto the soil, like an agricultural field. They're going to get run off of that by water off the land, okay, usually into a body of water. So we talk about the human impact of the phosphorus cycle. First one that comes to mind is going to be our fertilizer. Okay, as we talked about with the nitrogen cycle, that fertilizer is going to eutrify water sources if it lands in a body of water. That runoff is going to go into water, and the excess nutrients is going to cause algal blooms to grow faster, which is going to create an overall dead zone when those things die and decompose. Okay, leading to nothing living in that area. Okay, very hard to fix. Very hard to fix. Okay. Next one's going to be the mismanagement of manure. Okay. So when manure is just dumped into water, it can lead to eutrophication. Okay. So if you're not disposing of your manure or your biosolids properly, you could have big issues with eutrophication as well. Same process as described before. Okay. So next one's going to be the carbon cycle. We're not going to talk about it in this video. We're going to cut this video a little shorter, make up for time for the other videos that have been a little bit longer. Okay, so I will see you in the next video. Thank you guys.